Okay, hi everybody. My name is Rolando Manrique. I'm a software engineer here at LendUp. I joined recently, just like January this year. And yeah, let's talk a little about blobstore. This is a library that we open sourced a couple of months ago. So it was a great learning experience, and I think it's interesting to look at the implementations, the store implementations that we ended up doing, and with fs2 and some of the use cases where we're using this. First of all, let's get the disclaimer out of the way so lawyers are happy. Opinions are my own, not LendUp's official position. But yeah, having said that, let's definitely talk a little bit about LendUp. As you can see here, and the words behind the screen also say on the wall, LendUp's mission is to provide anyone with a path to better financial health. And one of the things that I've really liked in this short amount of time in LendUp is that this really come up all the time in our meetings. It's like, it's not just words on a wall, it's actually we ask ourselves in meetings, is this really the best thing we can do for our users? And is this how we can help them get to a better financial position? So yeah, our products basically are like this is saying, using machine learning algorithms and looking beyond just your credit score to help people with no credit score or people who are rebuilding their score get to a better place. One of the products that we have at LendUp that tries to help with this mission is our credit card offering. We have 2 credit cards right now that we offer to our customers, and one of the big pieces of the overall ecosystem of the credit card systems is running data pipelines that move data from external providers, banks, and different kind of heterogeneous mixes into our data so that we can offer that data to our users. And that's kind of what motivated the build of this library, blobstore, that basically had 2 main goals. One is to provide a common algebra to model network file operations. And we're talking about downloading COBOL files from SFTP servers in some bank, to storing data in S3, to moving data into Postgres databases. So this pipeline is very diverse and heterogeneous, so we really wanted to have a common interface that we could access, that could offer us the same interface to all these different disparate things, but also would also allow us to test our software a lot easier. Regardless of the store implementation that you have on the back, if you have a common algebra, you can provide a test interpreter for that algebra that will present some scenario that you want to test on. And for the second goal, I mean, we are a growing company, we need to scale. And we need to be able to support a lot more users than what we have right now. So we are piggybacking on fs2's README file, where we say we definitely want compositionality, expressiveness, resource safety, and speed. Definitely fs2 is the right tool for streaming in this case, and it was really helpful on taking us and providing those tools that we needed so that we can compose these streams in a way that makes sense, and we're going to have some samples of that in the next few slides. But basically, this composition of streams with constant use of memory has been key to allow us to build a pipeline that we know and we feel confident that we'll be able to scale to as many users as we need to. Okay, so this is a store, and there is a term that describes this very, very clearly. I don't know if anyone wants to take a guess about that, but I explicitly left that term out. The term is like finally tagless. So this is a finally tagless algebra, and the reason why I'm not putting those terms in the presentation is because I don't feel like I'm an expert in this kind of category theory concepts. Even the algebra and interpreted concepts are something that are new to me, but this project was definitely a great learning experience for me to work on this concept, build on top of this concept. And I think that without being an expert in category theory, you can produce very good code, very usable code, and it's great to see the response that people is giving us on this library that we built like in just a couple of months of work. So basically, a blobstore is any store that can support these 6 operations. And as you can see, this is all stream-based. Even listing a path in some directory in S3, you could, or any of our stores, you could have thousands of items coming out. So you want to be streaming that data out of your storage mechanism. You don't want to have this whole list of path in memory. Getting a path is basically just a stream of bytes. When you give us a path to a file, what you're going to get back is a stream of bytes that you can then run through any fs2 pipes to convert that binary code into text or whatever you're converting into. The put method is just going to return, excuse me, it's going to return a sync. So any standard fs2 stream of bytes, you can just pipe it into this sync, and then whatever bytes you pipe into it is going to be stored in that path in your store. And then operations like move, copy, and remove, these are just unit operations that are wrapped on your effect monad. And we could have implemented like a generic move, because it would be just doing a get and doing a put, but then we want to let the stores optimize for the use case. For example, in S3, you can use the S3 move operation internally inside of S3, so you don't have to transfer the bytes down and then up again. So that's kind of why we added these methods, even though you could, well, except move and copy, you could potentially build them based on get and put. We still want to let the stores optimize for those use cases. Basically, like we said, anything that any store implementation that provides all these 6 operations can be a blobstore. And then how do we guarantee that these stores are consistent and they have the same behavior, that you can swap them in and out, regardless of the interpreter that you're using underneath? It's because the library provide an integration test suite that you can implement on any store implementation. If you extend that test suite, then you will get a comprehensive list of test cases that will execute each one of these operations, and they will make sure that your test, if you're implementing your own store, that your store it's consistent with everything else that we've built, so that we can replace it with any other store as needed. Okay, what else do I want to? Oh, and also one more thing I wanted to talk about the store. It's also something that the library provides, is that we have an implicit syntax that you can import into your scope, and we will provide like additional methods like a get that uses the default chunk size of 4Ks, that is what most people use, and then you can have a put that receives not just the path but a file and the path, and that will give you an f of unit. We implemented some of those most common operations. One that we use a lot is transfer. So if you say SFTP store transfer to my S3 store and you give the path, the source and destination path, then we will use the get and put method to pull from one store and write into another. So that's, those are convenience methods that the library is also providing you just by importing the implicit syntax that we implemented. So let's look a little bit into the store implementations, and I wanted to start with a very simple, straightforward case, which is the get method. Most of the stores implementation use some SDK in the back. For the file store, we're just using, like, if you want to read a file from the file system, you just use fs2-io and read all from the file. I have an implicit conversion from path, from the blobstore path to a neo path, so I don't need to like do the conversion every time. It's implicit in the library. or it's implicit for file store, I should say. There's also the get for the S3 store is just using the get object content from the S3 SDK, and then that's just going to give us an input stream that we are just going to run through the standard fs2 IO read input stream. And the same goes for the SFTP store. So we can see that there are some operations that are very straightforward to implement in the store, and most of these network file storage systems have some way of giving you an input stream of the contents of the file that you want to download. So to look at a little bit more interesting case, this is the S3 store list function, so we start, for those of you that are not familiar with how the S3 lists API works, you basically have to call this list object function with a list object request. That will give you an object listing instance. That instance may be truncated if you're listing more than 1,000 items. So they automatically paginate that response. So you have to ask if it's truncated, then go and fetch the next one. But the function you use is a different function. It's not like calling the same function over and over and again. So the way we implemented this is like, we went on and used the fs2 unfold segment eval function. So we are basically unfolding a function, and you can see kind of the signature of this initial state is a function of unit to an option of the list objects that we want to extract from S3. Then in the first iteration, we are going to call that function get object listing. Is going to give us the initial object listing, and I should start. OK, there you go. In the next iteration, I definitely want to ask if it's truncated, and if it's truncated, then we can call the next batch of objects, and at some point, the response is not going to be truncated anymore, so we respond none, and then we know that we can terminate our stream. So this is one of those that definitely took a little bit more time to implement, and it's not as straightforward as the gets that we saw before, but it's really interesting how using the regular fs2 stream functionality, we can build a really streaming solution for this list function. And then a really, really interesting one, it's one that uses blocking APIs. And this is kind of like the exact same function we have for S3 and box store. Box is just for box.com. We use that to transfer data to our business stakeholders. So when we call upload file, we have a blocking call that is just expecting an input stream. And yeah, sorry that it's not very clear with these names. But basically what you pass in is an, excuse me, an input stream. And the SDK will just block your program while it reads from the input stream. And whenever that input stream is closed, then it will release, and then your file has been uploaded. So the way that I found or the solution that I found for this is using the plain Java and old like pipe input streams. We have like the input stream is just piped into an output stream that then we will write write all the bytes to this output stream function, and now we have two streams that we need to run concurrently. One that is reading the input stream, the other one is writing your bytes to the output stream, and then we use the concurrently function from fs2 to just run both. When write bytes is done, it will close the input stream, and then it will close the output stream, and then the whole stream is going to terminate, and your file is going to be uploaded to the box website. Notice also that we are going back to our goals. We wanted resource safety, right? So we are using the fs2 bracket function to initialize our pipes, consume them, and if something happened and we never reach this close method, then we will still release those input stream in the release function in the end. So we know that this is I forgot about my whole little blobs, but yeah. Okay, so we write and read, and then we safely release our resources in the end. So again, going back to the store goals, these implementations are all doing constant memory. They're being resource conscious, and they're definitely very fast. So one more use case is one that is not pretty. It's not the pretty way. It's the one that I had to write and like get it done because I still have like work to do and meet deadlines. So what happened here is that I use the default for the SFTP store. We're using JSCH as our SFTP client from Apache. So I use the default channel list for the list operation, which uses a default entry selector. This is just an interface that they ask you to provide when you're listing items. And this thing batches all your responses in memory. So this implementation is definitely not a good streaming implementation because, again, we have this batch of items in memory. We are living with this because we know that the SFTP servers that we're talking to do not provide us with that many files. It's just like a few files a day. So it's definitely less than the 1,000 that S3 uses as its default number. But yeah, this is definitely not cool. And we know this is a work in progress. There's a lot of stuff that we want to improve. But there is a path to solve this very easily, which is instead of using the default entry selector that they provide, we can implement our own entry selector that uses an fs2 queue. And then on every item, you just enqueue that item. And then our stream, the stream that we're going to return is just dequeuing just calling dequeue on the fs2 queue that you're going to be using for that. So definitely asking for PRs. More things that we would like to see implemented is like an HDFS store. We don't have that. We haven't had the need to implement it, but I don't think it would be very hard to do. So if one of you guys is using HDFS a lot and want to consider that, it would be a great addition. I don't know, just like we have box.com, we can have Dropbox, or one that I would really like to have to facilitate our mocking of these stores in a unit test would be an in-memory store that doesn't need to have like a file system or anything like that behind it. It's just saving this blobs of bytes in memory. That would be very convenient for unit testing. So use cases, and how do we use this in our pipeline? And really, this is one of the things that I'm really, really excited. I mean, the fact that we were able to implement this, when I thought about it, I said, well, in theory, it should work. This should be fine. I should be able to compose these two streams, and it should be good. So the fact that I was able to do it and it worked it's very exciting. So we have a very standard stream of database inserts. And here we're composing with Doobie to insert in our Postgres database. So we use the standard store get from whatever store we're reading from, whatever store was provided to this program. We build our own Avro binary decoder pipe that will take the stream of bytes, and then given a certain schema, it will provide us with generic records. Then we have this record handler type that is basically a function from a generic record to a connection I/O. So we use that, and we receive that here in our stream. We use that handler to, so given the stream of generic records, we translate that, and thanks to Dewey, that provides the conversion from I/O to connection I/O. We can translate that to a connection I/O stream, and then map our stream to the handler. And what this is giving us, it's basically that the insert stream is our database transaction. That's all the inserts we want to do in the database is giving given this one file that we're processing. But the requirement is that we keep very good control on the files that we're processing. We want to guarantee exactly once processing of this file. We want to guarantee that any time that a file gets processed, it then gets marked as done in our state machine. Basically, marking as done is just moving a file on the store from one place, the open directory to the done directory. So what we're doing here is combining a stream of database transactions with a stream of store operations, and then if either one of them fails, we want to roll back our transaction. So thinking about doing this with any other tool, you would have to like do the inserts, wait, hold the transaction there, go do this, and if it fails, then you have to worry about all these conditions. But in our case, we just translate the store operation stream into a connection IO stream because the connection IO is just like any other effect monad. And we concatenate these two streams, and then we transact on the whole thing. And like very impressively for me was that this actually works. Anything that happens when you're trying to mark your file as done will actually revert your transaction. And this is like demonstrating how composable the streams are and how you can mix different streams from different types of operations. But the other goal of our pipeline was also that we wanted this to be easy to test, and we want this to be really easy to mock and provide, make sure that you can test without having all these dependencies and all this baggage in your unit test. And basically for this one function, the way we test it is by providing a custom store interpreter that models a very specific scenario in which you have good input data. So these records that are coming through our stream, we know that they can be inserted and it's going to be fine. There's not going to be a problem with them. We also provide, in the same store, we also provide a failure scenario on a specific command when you try to move this file from this path to this path, and going back to our move function that we have in the slide before, it's matching that scenario, then we want to raise the error. Hey, this failed. And this is how we simulate our failure scenario. Then we provide the store simulation into our workflow class. And then we can execute this. And basically what the test is doing is that after I run my workflow with this specific store, I should run a bunch of queries that validate that none of the data that was supposed to be inserted in this transaction should be inserted. And I know because the inserted records in the end must be 0. So not only you can compose and do all this great thing with the fs2 streams, you can also have your custom test store that will provide the exact scenario that you want to do to confirm that your code is working and you know that your unit test coverage is very good. So yeah, I think it was a very interesting process. I'm really glad that Lendo supported open source in this, and happy to see the response that you guys have to this library. This is all I got for today. So thank you very much for coming, and if you have any questions, I'm here.
Not quite a question, but you mentioned testing against an in-memory data store. Looks like you already have a nice NIO implementation.
Yeah.
We built in like in-memory NEO, like GIS.
Yeah. So the comment is that definitely doing the in-memory implementation should be super easy. And yes, that's something that we know it should be easy. Kind of that test store that I showed, it's an in-memory store. But it's with a fixed set of data. we know there's definitely tools that would allow us to do that very quickly. It's just that as soon as I got the bare minimum, I had to go meet my deadlines. So that's why we haven't gone beyond that. One of the things that we also want to improve a lot, and that's all on me, I have to get down to it, it's actually running those integration tests that I was talking about that are generic for any stored implementation. Those are integration tests. So right now, running them in Travis, it's hard. It's not impossible. So I have to make some time to actually set up some test bucket that I can put my secrets in Travis and actually execute the integration test on my public Travis builds. If you go to our README right now, our test coverage says 26% or something like that. The reason is because we're not running the integration test on the public Travis, but when I run it in my local environment, setting up all the integration tests, we go up to 80s, mid-80s. So yeah, it's definitely something there's a lot of stuff that I would like to do to it, but yeah, time is limited.
Yes. A couple of questions. What is the compile time like for these constructs that you have? Because they seem very high level. Is that an issue?
For the store itself, it's not that hard. It's not that long. The compiler actually behaves very well with the finally tagless approach. There is not much that the compiler is actually doing in our case because this is just an interface and then a specific implementation of that interface. Having said that, we have Avro schemas with almost 200 fields. That it's just all the data is coming from the bank for a given thing. So compiling those are becoming increasingly annoying. So I was very interested in Jeff's talks before because it would be nice to see. And we're using for the Avro encoding and decoding, we're using the Scala 4S macros, just their macros module. And basically, it uses shapeless under the cover, and we know that as soon as you put in shapeless with more than 100 fields, then compile times are growing exponentially. So we would definitely love to see compile times go down a lot.
Yeah. Second question. You had mentioned the connection with category theory. Yeah. I was wondering, can you point out some references that might help to understand the motivation for structuring this way?
Yes, definitely the finally tagless concept. It was described by Oleg. I don't recall the last name, but they call it the famous Oleg. He described this a few years ago, and it's kind of in opposition to the free monad, or not in opposition to the free monad. The argument is that if you don't have an algebra that when you are interpreting it, it's really composed, and you're just flat mapping over your type classes, then it's probably not necessary to do a free algebra to do this kind of specific examples. And in our case, it's definitely not. It's either one of these type classes would be the 6 operations that we have. So when I was looking into this and seeing that it's definitely not, I read this from Paul Chusano's blog post on comparing free algebras to finally tagless. And he definitely explains very well how you can build the same solution on both, but how if you have a very flat algebra, it probably makes sense to just use finally tagless, and that's what we went for. It's definitely a lot less boilerplate code when you're doing it this way. Well, I don't have anything more. So,
Let's thank the speaker.
thank you very much. Thank you for coming.